let's learn about right triangle trigonometry. For example, let's find sine theta, cosine theta, and tangent theta, where theta is the angle shown in this triangle here. Now, whenever we have a right triangle, and one of the other angles is known, then that determines the other angle, because all the angles have to add up to 180 degrees, which means this other angle here would have to be 90 degrees minus theta. Therefore, the shape of the triangle is completely determined, except for similarity, by the angles. So once the angles are known, the ratios of the sides are determined regardless of the overall size of the triangle. And we have names for these ratios. But before stating what these ratios are, let's label or give names to these sides of this triangle here. So the side that's across from theta, or opposite theta, I'm going to label as opposite. The side across from the right angle is called the hypotenuse. And the third side next to theta, or adjacent to theta, we call the adjacent side. And now we're ready to name these ratios. So we have that the sine of theta, sin is short for sine, is equal to the opposite side divided by the hypotenuse. The cosine of theta, and cos is short for cosine, is equal to the adjacent side divided by the hypotenuse. And the tangent of theta, tan is short for tangent, is equal to the opposite side divided by the adjacent side. Now there's a mnemonic that is commonly used to help us remember these ratios. And the mnemonic is as follows. It's SOHCAHTOA. The S here stands for sine. The O stands for opposite. And the H stands for hypotenuse. So looking down here, we have S, O, and H. That is, the sine of theta is opposite over hypotenuse. Now the C here in K stands for cosine. The A stands for adjacent. And the H stands for hypotenuse. So looking down here, cosine C is equal to adjacent A divided by hypotenuse H. So this is adjacent divided by hypotenuse. And finally, with the TOA, the T stands for tangent. The O stands for opposite. And the A stands for adjacent. So coming down here, we have T for tangent, O for opposite, and A for adjacent. So this is opposite over adjacent. So now with this background information, we can solve our problem. We can now find sine of theta, cosine theta, and tangent of theta. Looking here, here's theta, which means this 3 is the opposite, or O. This 4 is the adjacent, or A. But what's the hypotenuse H? Well, the hypotenuse we can find by using the Pythagorean theorem. Namely, 3 squared plus 4 squared is equal to the hypotenuse squared. Or 9 plus 16 is the hypotenuse squared. Or 25 is the hypotenuse squared. Which means the hypotenuse then would be the square root of 25, or 5. Therefore, coming back over here to these ratios, the sine of theta is equal to opposite over hypotenuse, which is equal to, in this case, 3 divided by 5. And the cosine of theta is equal to the adjacent over hypotenuse, which is equal to 4 divided by 5. And finally, the tangent of theta is equal to opposite over adjacent, which is equal to 3 divided by 4. So these would be our 3 answers here. By the way, the word trigonometry comes from the Greek words meaning triangle and measure, and you should see why now. All right, let's look at another example. Let's find x and y in this figure here. Well, let's start by labeling our given angle, theta. And this number 4 here is the length of the side opposite theta. So let's label it O. And y down here is the length of the side that's adjacent to theta. So we'll label it A. And x up here is the hypotenuse, so we'll label it h. So by what we just learned, the sine of theta, or the sine of 30 degrees, is equal to opposite over hypotenuse, which is equal to 4 divided by x. The cosine of theta, or the cosine of 30 degrees, is equal to adjacent divided by hypotenuse, which is equal to y divided by x. And the tangent of 30 degrees is equal to opposite divided by adjacent, which is equal to 4 divided by y. Now we can use this first equation to solve for x. So we have sine of 30 degrees, which is 1/2, is equal to 4 divided by x. And then cross-multiplying, this gives us that x is equal to 2 times 4, or 8. Now to solve for y, we can use either of these last 2 equations. That is, we could use this middle equation. So cosine of 30 degrees is square root of 3 divided by 2 is equal to y divided by x, but we just found that x was equal to 8. And cross-multiplying will give us that y is equal to 8 square root of 3 divided by 2, which is 4 square root of 3. Now this computation, though, required that we knew what this value of x was. If we use this third equation, though, we didn't need to know what x was. Because tangent of 30 degrees is 1 divided by square root of 3, and this is equal to 4 divided by y. And then cross-multiplying, we'd get to our same answer of y is equal to 4 times square root of 3. And this is how we work with these trig ratios. Thank you, and we'll see you next time.